Okay, so as you can see here, different houses, different workloads associated with different houses, and they have the appropriate names: Gryffindor, Hufflepuff, Slytherin. We've got our special Dumbledore allowance here that we talked about, and this is what you can see in vSphere. You can see that Slytherin Web 01, which we'll be looking at here in a moment, is on ESXi host 01A. If we go into NSX and take a look at the distributed firewall policy section, you can see that we've got some common services here in the infrastructure category. So I'm putting my common services like we talked about in the infrastructure category because I know that pretty much all of my workloads are going to need access to these. So as an example, I've got DNS. All of my workloads need access to the DNS server, of course, so I've allowed access to them. Now, I happen to also be using SSH to demo this environment here and to show this off as a lab. Maybe in a production environment, I'd want to limit SSH access as much as possible. But in this case, I've only applied it to the Slytherin web servers. So it is limited to a certain extent here so that we can just demo this lab. But again, policies like DNS, Active Directory, NTP, services like that are going to be what you put in your infrastructure policy category. So let's move on to the environment category here. And you can see that I've got Gryffindor policy here. Let's expand that. Hufflepuff house policy as well. Slytherin, and then of course Gryffindor to Dumbledore. So you can see that what I was talking about as far as these being all positive rules, in that Gryffindor to Gryffindor is a jump to application policy here, right? Hufflepuff to Hufflepuff jump to application. Slytherin to Slytherin, I've got this set to allow to show you what this was like prior to NSX-T 3.1, and we'll get to that in a second. And then of course I've got Gryffindor to Dumbledore, and then Dumbledore to Gryffindor, so that special access that we wanted to have set up is allowed here. Notice that I don't have any rules that are saying Gryffindor house cannot talk to Hufflepuff house. And again, the reason for that is that I'm relying on my default deny rule to prevent that traffic from happening. And it won't happen with this setup. And if I go to my application tier, I've got my intra-application rules for each house. Slytherin house is the one we're going to be mostly focused on here. And you can see I've got my client access with the sources any, destination is web servers. I've got my web to app, and then I've got my app to DB. Again, there is no web to DB rule here, and that's the connectivity that we're going to be looking at. And just to show you what we got here, we do have the default rule set to drop. So any traffic not explicitly allowed here is expected to be dropped. All right, so let's take a look just to verify that our applications are working as expected. So I'll go to Slytherin web app here, and you can see that my application is working as expected. Slytherin web 2 as well should also be functional. So we can see that even with policy applied, this is a published rule set. That the applications are working as expected. So let me return back to NSX here, back to the environment section, and focus on this Slytherin house all to Slytherin house all allow rule. Again, the other houses, I've got them set to jump to application, which is the preferred action for environment rules in 3.1, and that's the new feature. But let me show you what the difference is between how it worked prior to 3.1 and this new jump to application feature. Because the only action that was available before then was allow or drop, right? So I've got Slytherin house to Slytherin house allow all. And then I've got my policy in place for intra-application in the application category. So let's take a look at Slytherin Web 01 here. And I'm actually going to ping the DB server. So the DB server, I believe it's on 172.16.30.11. Right here, you can see that. So that's the IP address that I'm going to ping. And you can see that the ping is successful. Yet I don't have in my application section of my rule set, I'm not allowing Slytherin web to DB service here. You can see I'm only allowing any to web, web to app, and app to DB. There's no explicit allow rule for web to DB traffic, and yet I'm still able to ping the DB server from the web server. So an attacker could use access, say, to the web server to then laterally migrate over to the DB server. That's a potential flaw here. So instead of having this set to allow, what I can do is have it set to jump to application. And I'll go ahead and publish this rule set here. As you can see, it's now jumped to application. And now if I run this ping from the Slytherin web server to the Slytherin DB server, I can no longer ping it. And that's because we're actually matching two rules. The flow is actually having to match two rules. That first one that's allowing access within the Slytherin domain, and then our more specific application policy where that rule is not actually defined. The traffic is being dropped as expected by the default rule here. And just to verify too that I can't ping from Slytherin to, say, Gryffindor, we'll ping this one here, which is 10.0.1.11. And of course, I can't ping it as expected. Even though I haven't explicitly denied that implicit deny at the bottom of the rule set there is performing its job as expected. Let's verify just to make sure that we can still access this application, and we can. So the jump to application feature action had no effect on the application connectivity. So that's kind of the benefit of this jump to application feature. We're actually getting further to zero trust here with this. Let me show you what this kind of looks like on the data plane. So we'll go to the host here, run summarize DV filter, and I'm going to locate the Slytherin web since that's what I've been working with. You locate the slot 2 filter, vsip ioctl get rules -f, and then the filter name that I just copied. And then you can see all the rules that are associated with that workload, with the Slytherin web workload. Here's how we do the different categories before you get to application. So you notice here that you've got your pre-filter rules, and then you've got your filter rules, and it says app category. All your pre-filter rules here, these are your infrastructure rules, your emergency rules, environment rules, right? You can see I've got the Hogwarts DNS, Hogwarts SSH there as well for the infrastructure rules. But notice that that for this one here, this is my environment rule, where I've got the jump to application, and this is my address set, which is actually representative of the Slytherin house all. You can see that that's the source, and that's also the destination. And then of course, here's the action. So go to filter, jump to application looks like on the data plane. And that means it's going to jump immediately to this application filter here and to this rule set. So that's kind of how this works at the data plane level, is that we have two different filters, one for all those for the emergency, infrastructure, and environment sections, and then another distinct one for the application one. And layer 2 has its own as well, but of course there you're dealing with MAC addresses and at a different layer.
Thank you very much, Harrison. That was a great overview. All of our listeners, audience, now you understand what is macro segmentation versus micro segmentation. Also, you can from here onwards start looking at jump to application feature in NSX-T 3.1. Once again, thank you, Harrison, for showing us this great demo.
Excellent. Thank you, Victor.